Hi guys, we're going to talk about volume of pyramids today, and we have some vocab for you to look at. This first vocab word was exciting to me because I don't know that I use this vocab word. It's called an apex, and it is the point or the vertex that is farthest away from the base in a three-dimensional figure. So today we're talking about pyramids and the amount of stuff inside of a pyramid. So when you're looking at the apex, you're looking at the tippy top point right here, and that's what an apex is. Now, the height of a pyramid actually is if you would pierce a pyramid like right through the middle, it goes straight down into the middle. It's the height if you were at the top and you dropped all the way down. The pyramid itself has a base and then all triangles that connect it. So we talked about square pyramids and rectangular pyramids. You could even have a pentagonal pyramid if you wanted. And volume is how much space is inside the figure. So here's a 3D shape again. All the triangles will meet at the top. This is a square pyramid because the base is a square, and this is a rectangular pyramid because the base is a rectangle. We talked about this apex, that's that point right up here. The base is the bottom of the pyramid. If it was upside down, the base would be the part farthest away from the apex. The slant height, we usually use S. And the slant height is different than the regular height of a pyramid. The slant height would be if you took a tape measure around the triangle. It's the height of the triangle, but it's the slant height of the pyramid. And the height is the perpendicular distance. See, there's a right angle in here. If you drop something from the apex right down to the middle of your pyramid. So this is a cool volume formula. I don't like this, so we're not going to write this. We're going to write it like this. The volume of a pyramid is similar to the volume of a prism, and that's what this is saying. So it's similar to big B times H, where B, the big B, remember, is the area of the base, and H is the height of the pyramid. But this time, we're going to divide by 3. So it's big B times H divide by 3. I always tell my students, if you don't want to sit on the figure, because nobody would want to sit on a pyramid, then divide it by 3. Now, why do we divide it by 3? Because a special relationship between this pyramid and this cube exists. So like if the cube and the pyramid had the exact same base, they are related somehow. And I found a little video to show you. Let's see if it will play for us. And here we go. Oops. So there's your pyramid. And there's a cube. They have the exact same bottom. We're going to fill that pyramid all the way up with water like a volume. And watch how many it takes to fill up the cube. Some people would think that there would only take 2, but it actually takes 3 of those to make one of those. So it takes 3 pyramids to fill up 1 cube. So whenever you're looking at the volume of a pyramid is less than the volume of the prism, so we have to divide it by 3. So here, if the bases and heights of a prism and a pyramid are the exact same, and the volume of the prism is 27, what would the volume of the pyramid be? Well, you would take that 27 and you would divide it by 3, and you would get 9 cubic units because it would take 3 pyramids to fill up 1 prism. Now they're going to write it like this: 1/3 big B times H, and that's the same thing as big B times H divided by 3. My students just usually are a little more successful if they divide by 3 instead of messing with the fraction. So let's find the volume of this pyramid. Okay, so the volume is big B times H divided by 3. Big B is area of the base. So big B here is going to be area of, what kind of shape is it? It's a square pyramid. This is a square pyramid because the bottom is a square. So how do you find the area of a square? That's just base times height, which will be 12 times 12, which is 144. Big B is 144. Take it times the height of the pyramid, which comes from the apex right to the middle. That's 144 times 15. We're going to divide it by 3 because it's not a prism. It's a pyramid. 144 times 15 divided by 3 is 720. We're talking about the number of cubes that would fill it up. That is feet cubed. So big B times H divided by 3. This one they started for us. So they took the big B, which is the base area, which is a square, and they took 6.5 times 6.5, which is 42.25. So big B is 42.25. We're going to take that times the height of the pyramid, which is 6. Then we will divide it by 3. So 42.25 times 6 divide by 3, and we get 84.5 meters cubed. I get that from typing it in my calculator. Ty knows the volume of this tent is 64. We're going to find the height. Well, volume is big B times H divided by 3. Well, the volume of this tent is 64. Do I know what big B or H is? I do. I know what big B is. Big B is the area of the base, which will be the area of the rectangle here, which is base times height, or 4 times 6, which is 24. So 64 is 24 times the height divided by 3. We're going to get the height by itself. So we got to get H all by itself. So we need to move the 3 first because it's underneath, and we'll move it by multiplying both sides by 3. 64 times 3 in my calculator says it's 192, and that's going to be 24 times the height. Divide both sides by 24, and you get your height equals to 8. What's the 8 mean? Is it a units cubed? Is it a feet cubed? Is it feet squared? Or is it feet? They wanted to know the height. The height is a one-dimensional distance, so we just call that 8 feet. Wren built a birdhouse with a volume of 224 inches cubed. Find the height. We just talked about that. Volume is big B times H divided by 3. If the volume is 224, that's going to be big B times H divided by 3. Do I know anything else? Yeah, I know what the big B is, the area of the base. Big B is the base of a square. So that's base times height, which is 8 times 8, which is 64 inches squared. So 224 is 64 times H divided by 3. How can you solve? Let's multiply by 3 first. 224 times 3 is 672. 672 is 64H because those 3's will cancel. Divide both sides by 64. 672 divided by 64 gives me 10.5 for the height, and that is inches. Okay, moving on. This time it's an upside down pyramid, but that's going to be okay. He built a wooden shelf with a volume of 7.7, and the height is this. This time we're going to find the area of the base. So volume is big B times H divided by 3. The volume is 7.7. Area of the base is the same thing as big B. That's what we're looking for. I do know what the height is. The height is 3.3. We will then divide by 3. This time we're getting big B by itself, but the process is the same. Multiply both sides by 3. You'll take 7.7 times 3 in your calculator, and you'll get 23.1. And that is 3.3 times big B. Divide both sides by 3.3, and you get big B equals 7. 7 is the area of the base. Area is measured in feet squared, so that will be 7 feet squared. Mandy built a pyramid for her project on Egypt, and the volume is 48 3/4 inches cubed. Well, let's change that to a decimal. Let's say that's 48.75. We're looking for the area of the base. Big B times H, we know, is 6 divided by 3. So did we use the formula V equals 1/3 BH? Yeah, we're going to use that. We're just going to write it a little bit different. The volume is 48 3/4. That is correct. The height is 6. So we'll plug those into the formula, and now we'll solve for B. Let's see what the area of the base is going to be. Multiply both sides by 3 to get rid of the 3. 48.75 times 3 gives me 146.25, and that's big B times 6. Divide both sides by 6, and you get the height equals 24.375, and that will be inches squared. Now, you can probably tell that this is closest to that guy, but what if you didn't know that 0.375 is 3/8? In your calculator, if you take 3 divided by 8, you would be able to see that 3 divided by 8 is 0.375, and that is the correct answer. Okay, that's it today. Thanks for working with me and pyramids.